Good afternoon, everybody. Hello to those of you who are on the live stream. Yes, this isn't exactly the same talk as you might have signed up for if you are joining for listening about Painter. You get a brand new experience of listening about error handling. I hope this goes well. Sometimes when you prepare a talk with 2 hours notice, it goes badly. We're going to get through it together. We could say that this is itself fallible. It's okay. My name is Tim McNamara. I run a little consultancy where we teach and consult on Rust, all the way from in fact, the biggest, largest software companies down to indie game developers and so forth. And one of the things that is very important for people as they adopt Rust is understanding how to deal with errors. We start off with a very strange experience of not having exceptions. And yet, people say that Rust is a decent programming language. So I would like to spend some time talking about what your view of an error is and what the type system's view of an error is. Because these two things are actually distinct. Then I want to unpack result and sort of describe, and here it's actually, I've got a typo. Result, as it's defined in the standard library, or standard result has T and an E. But standard I/O result has a T, and standard format result has a T. And so one of the things that I want to show you is there is some sanity, even though you have 14 or something different definitions of result in the standard library, and other crates themselves have their own results. And then we're going to talk about starting with just ignoring the problem all the way through to ergonomically handling it. At least that's the agenda. But first I kind of want to chat, just a very small story. And when I started Rust, I was like, wow, I'm going to do something exciting. I'm going to write my own name to the screen. And, oh. It's like, I don't care about this Rust. Like, I just want to print it out. Like, should be, why? So Rust is very, very particular about requiring you to opt. It requires that you deal with the possibility of an error. So there is one difference between the result as defined in the standard library and other enums that you are likely to define yourself. And that is result has an annotation must use. It's essentially the only thing that makes it magical. And if you decide to ignore it, you'll receive a compiler warning. And so, just let to underscore. Okay, sorry, let underscore. And this actually works fine. This is what I mean by ignoring the problem, essentially. This gets the compiler, or you just kind of wave it away. And then I thought, you know what, actually I should deal with this properly. I want to return format result unit. I can kind of sort of understand what's happening here. If you're new to Rust, the very last line returns the OK variant of result. Result has two sides, an OK side and an side. And the brackets or parentheses with inside OK is the empty tuple, or empty tuple. I can never say. And the term from mathematics is either the empty set or the unit type. And so essentially I'm saying this is a successful completion of the program. But later on, I really want to start expanding my program. And so I want to write potentially to a file. Here I am trying to open temporary hello.txt, and I want to write into that file hello Tim. And I'm like, this is complicated, but I think I can get there. I initialize immutable, I create a file, and then I open it up, and and then, so the other thing I do is I write into it, and then I read it out, and I print the result from the file. And all of a sudden, I receive some sort of crazy compile error. The problem is that, so if you try to compile this program as is, you tie yourself up because the I/O module returns its own error type, and so does the format module, and they collide. You kind of want to be able to return either or. This is not legal Rust syntax, but me as a beginner, I'm like, this is absolute nonsense. They're just results. This is kind of what I want to do. So the reason why I'm sort of telling you this is, and then I sort of learn about this kind of crazy syntax. And for me, I came from Python, so I didn't know what a box was. Rust taught me what a pointer was. And a box is an allocation on the heap, essentially is a link from the stack, the local variable space, into the heap, where it's kind of the space for sort of shared variables. Dynamic is an indicator of a trait object, which is I'm returning something which implements the error trait. And dynamic is a hint of dynamic dispatch, and is essentially a way of expressing the idea that I could return either a standard I/O result or a standard format result. And it will be resolved at compile time. The only problem with using a trait object, just generally, is that you lose the concrete type. You can only access methods that are defined on the trait itself. What is an error in Rust? You could think of an error as the side of result. You could also think of as an error as something that implements the error trait. These two things are actually distinct. Sadly, it's really complicated. The error trait has a very specific purpose, which is to be displayed in a log file or on standard out or standard error. That's essentially the only thing an error in Rust needs to be. Any type at all can be an error if it implements display. And so that's why sometimes we can return strings as errors. Because the role of an error for the type system is, or at least the role of things that implement standard error, is to be displayed to an end user. Because something has gone critically wrong, or at least something has gone wrong in such a way that we might need to report it in a log file, say. Whereas result, if you go and check the standard library on your phone now, we can actually do it. Let's go have a look. Standard, Rustlang, and I go and look at result. And I see here that there's a T and an E side. And in fact, one side is success and the other is failure. But note on the definition that there is no trait bound on error on the E side. The side of result does not actually require that you implement the error trait. So it is mind-bending. And in fact, there are some really clever tricks that you can play. For example, in this, actually, no, I'm getting off task. We can talk, if there's time at the end, we'll talk about some of the clever tricks of essentially allowing this side to not implement error. Okay. So this is the full thing. It actually works. Yay. I've changed the program slightly. I've been able to get 42 And right down the bottom here, I'm parsing, and I am, I'll see if I can get my highlighter to go. There we go, laser pointer. The parse method is trying to parse in an I32 from the text file. And in fact, so now we've got 3 different implementations of error that our program could generate. But we sort of have this kind of interesting union of types through the trait system, through the trait object. But the programmer's view of an error is different. It's something that is exceptional. It's against the norm. We don't think that this is a normal behavior. It might also mean that there has just been something that is completely unexpected, and it's an error. Like it's, we don't know what it is. Whereas the type system is something that implements the error trait, and sometimes this is indirect because the type constraints themselves only require that you implement display. Result itself is just an enum that happens to be implemented multiple times, at least within the standard library. And let's go have a look what I mean by that. I'm not going to open up Steam, sorry. All of these results, oh gosh, no, apparently I am opening up Steam, look different. The pattern that the standard library adopts is that, so here's the central, standard result is an enum. It's a concrete type with 2 sides, T and E. If I am the I/O module, the result is a type alias, and I specialize the E side to something that I control. And so essentially, I reduce the degrees of freedom. And so the pattern that the standard library follows is that individual specialized modules, they know the kinds of errors that they can generate, and they provide their own error type. But remember, and so they have often structs, sometimes enums, but typically structs, which are also called error. So we now have multiple things called errors. We have structs, concrete types defined within a specific module that is loosely associated with the error trait. But there's no implication that the structs actually implement error. In this case, it does. The I/O error does actually implement error, which is annoying to kind of have to say. But what I'm trying to point out here is that it's okay to be confused. Like, it actually is very complicated. Because result is just an enum defined in the standard library. The language, the compiler, doesn't know what a result is. Essentially, it boils it away and treats it like the same as, oh, my computer's deciding to freak out. Result is just an enum, and the exhaustive pattern matching of Rust is what actually provides the strength. Okay, so now I want to get onto these multiple levels. One is ignoring results. Let's go and have a look at what this looks like. I have some function which can return, I've got work here. Oh God. When my computer overheats, I think it's the graphics card, just kind of starts to go, I've got some work, and this can kind of, like, which say will return sort of standard error, standard result. And we have OK. In our case, we'll say OK, and then unit. You might have seen this before. Some people just use unit as the error side as well. And OK. So we always succeed. And on the main side, we are going to return the same type. And that looks a bit ugly, so what we'll do is we'll define our type. Oh, actually, we won't. We'll do our type like this. And I will get to the point very soon, I promise. So work is a function which we care about, and let's say, appreciate it. And it's actually quite nice programming with other people. They're very kind. Sorry? So the compiler is a little bit confused because this also needs to return OK. And here I get the same error as we started with. That is, or at least a warning saying this is unused. And so I'll start first by ignoring the problem. Let underscore work will indicate to the compiler that you are making an active intentional choice to ignore the potential problem. This is on you as the programmer. If there is an error and you decide not to handle it, that's on you. So that is essentially what this underscore does. You are accepting responsibility for getting the information. Now, I said that we could have, let's say, invalid struct, invalid, and I can define, derive, debug, and then I need to implement display. Sorry, this is going to take me 2 minutes, probably less. Display for invalid. Come on. Am I giving a typo? Use standard path, that's not what I want. I know what I need. Standard format display. Impala. The implement missing members, and now I can write to this formatter thing, and I'm just going to rely on the debug implementation for my display implementation. And now I can return invalid. The compiler is happy, but I'm going to introduce some syntax or some code that you would have seen before, unwrap. What is the significance of unwrap? This isn't a trick question. Unwrap, happy to answer anything from the floor, maybe. I should watch the live stream live. Unwrap says, I know that this will succeed. And so go into the result and pluck out the OK side. So I'm essentially unwrapping the container. So you could conceptually think of this result as being some sort of container. And we're going in there and we're getting it out. We're opening it up and pulling out the unit. And what happens when, everyone would know that in this case we're going to panic. The thing will crash. And so one of the ways out of this is to start with an expectation of the error, which is, let's say, unable to work today, on strike. And now we get so we're on strike. We received an invalid. And we were unable to complete our work. So the only distinction between unwrap and expect is that expect provides a little bit of extra context to the output. But it does the same thing. But we are providing, we're kind of incrementally improving the treatment of errors. It's very common while you are getting started to use unwrap and expect. You're typically writing programs for yourself. You're writing command line utilities or maybe even small web APIs. And if the thing crashes, you fix the bug. It's okay. But one thing we can't, but you might have seen that pattern before where I provide this trait object. Because there are several sort of tutorials that say, oh, sometimes you just return a trait object. And this is error, error. And now I'll just demonstrate this. If I don't implement display, hopefully the compile will fail. Otherwise, oh no, it still compiles. That's very strange. Ah. So the question mark, sorry, apologies for getting a bit confused. Our work here is currently unused. If I try and open it up, we get this kind of issue that the type that I'm producing, this invalid, doesn't actually satisfy what the tutorial says that I should do and just provide a trait object. And the question is like, why is that? If you find yourself in this sort of situation, remember that you've satisfied the trait bound, standard error for invalid. There's actually no methods to implement. Now, hopefully, it compiles again. So you notice that the compiler error is wrong. So we need to opt in to the error trait, and now the type system can treat this invalid thing as an actual an actual trait object. And so the intuition that I'm trying to provide here is that the result type itself is not magical. The trait system is learnable. And if you start to define your own types for errors, you can start also to provide very, very specific diagnostics that are very useful to you. These errors are intended for your usage. Then, but there was something a bit odd, and that is I have an invalid, but I'm actually converting to a trait object. And so this sounds a lot like something that Rust doesn't enjoy doing. If you give it an integer, and say I've got A here, and it's 1, 2, 3, and this is an I32, and B is unfortunately for the type system a U32. Rust is going to complain very, very loudly that A and B don't play together very nicely. Rust doesn't like performing conversions. And so one thing to know about the question mark operator is that it's more powerful than just propagating up the error side to the parent scope. So it essentially is a short circuit for unwrap, whereby instead of panicking directly, it will push the error that I received from here's a better way to explain this. Match on work. If I match on work and there is an OK, then I return OK. On the error side, let's say I have some error, and this is an invalid. I somehow want to send back a, let's say I want to do this. This is what expect is doing. So this is expect. When there's an error, I crash. The question mark operator returns the error after conversion. So it also provides the ability for anything that implements error to operate as a trait object. So there are not many instances of what I would call hidden control flow in Rust, but this is one of them. The question mark operator also performs a conversion step to sort of unify the error types. And part of this is if you are defining your own error, you can implement the conversion utilities, the conversion traits. Say, for example, you could implement from for the kind of higher types. There's a little bit more. I'm teaching a lot about the result, which is useful, but actually I may have started with level 3. I might need to go back to level 2. There is one other point that I just thought would be quite useful. No, we'll get there. I'm sure that we will. So part of this thing of, let's say level 2 is, or level 1, we remember we were running expect with our custom error, essentially, or we were ignoring it. And what if I comment all of this out, and instead I return a string? And string from on strike. This is a perfectly acceptable thing to do while you are building your, while you're sort of exploring the code. Strings can be used in the error side. They implement display, so they can be used as errors, and are arguably you lose some type safety because maybe tomorrow I wish to change this from on strike to something else, and a genuine enum would be a better thing to do, or we could say that the factory, no power to the machines. This is why we couldn't work today. We had a fault, or some. It would be nice if we could encode these problems in the type system, but right now, when you're starting, you don't need to. Or at least I would argue that there's other parts of Rust to learn. And the way to, so let's go up. So there's 3 is enums as errors. So instead of just having we can use a struct, but it might be interesting to say, the reason why we didn't, no work today. There was a strike, or I don't mean to be mean to people on strike, but it came up and we've got it stuck. It was like we had a power outage. And the other thing was a mechanical fault. Again, we can actually reuse this pattern of just deferring to the debug implementation for the display implementation. It's a good way to get you through the process. It's a better thing to do sort of match on self here. and it's no work today. And actually take specific action depending on the enum, but right now we're doing example code. So over time, we increase the maturity of our little application. We started with nothing, we've moved to strings, we've moved to enums, we are providing proper diagnostics, and this is really useful to kind of develop the maturity of your code. As you learn more about the way that error handling works and some of this control flow with the question mark operator and a whole bunch of other bits and pieces, like how many results are actually in your code. The other thing to do I like understanding the way that things are operating before going to helper libraries. Because when you gain an understanding about how Rust works, it feels less magical. I don't like magic. It makes me feel very uneasy as a programmer. But a good thing, so here we have a cargo add, and I want anyhow. Anyhow is a really wonderful crate. If we, oh, that's the wrong place to go and visit. Excuse me. No, I'm getting very, very confused. I'm getting a bit lost. Crates.io, crates, anyhow. Anyhow provides you with something that looks almost identical in its behavior as that trait object approach. Because, ding, 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 it uses the trait object's dynamic dispatch to implement what it is that you want. Except that it also provides you with the ability to add extra context messages directly at the call site. Lastly, there is another crate as well called this error, which expands on the enum approach, where in this case, it's sort of we're interacting with some data, we're implementing a data store, there might be some disconnection that in the original era was from the I/O or standard I/O module, or unfortunately there's some invalid data, and then we have this kind of procedural macro for producing implementations of display and debug that makes sense. These crates, anyhow, and this era are both extremely useful. There are sort of another very a very strong competitor as well, called Air, which is slightly more comprehensive than just providing a context. We can kind of create, we can do more than, yeah. But there's a whole bunch of stuff here for you to explore, and oh, there we go. There's this error and anyhow an error. So these two operate in the same way. They're kind of spiritual competitors. And they both use trait objects, whereas this error makes it easy to create an enum that could potentially compose errors that come from other places as well. Here are 3 really wonderful blog posts that take a very detailed look at error handling in Rust. They do take several minutes, do dedicate, and it's going to sound silly for a blog post, but there are thousands of lines of code, thousands of lines of very detailed, very specific, and very well-written material. And that is 4 levels of error handling in Rust.